Hello, I'm Connor Mead, and we're here at the Canadian Science Policy Conference in 2015 with Dr. Alan Bernstein, President of the Canadian Institute for Advanced Research. So Dr. Bernstein, thank you for joining us.
My pleasure.
So to start things off, I was wondering if you can tell us a little bit about your career, some of the roles that you've played, and where you're at right now and how you end up there.
Well, I started off life as a scientist, biomedical research. I've been interested in cancer, stem cells, and blood cell production, and the genes involved in all of the above. I've had a lab for a long time, trained a lot of great students and postdocs. Then I became head of research at the Lunenfeld Tannenbaum Research Institute at Mount Sinai Hospital in Toronto. And then when the Government of Canada created the Canadian Institutes of Health Research, CIHR, they asked me to become the inaugural president, and I did, agreed to do that. It was a challenging, very interesting position to start a whole new federal agency involved in funding health research in Canada. I did that, of course, with a lot of great colleagues, the scientific directors and my staff here in Ottawa. Did that for 7 years. And then I stepped down. I thought it was time for someone else to take over, and I had done what I wanted to do. And so the Bill and Melinda Gates Foundation then asked me to set up another organization called the Global HIV Vaccine Enterprise to really get the world's major funders of developing HIV vaccines to play together nicely, to work together. So I agreed to do that, and I did that for almost 4 years based out of New York City. And when I finished that, the Canadian Institute for Advanced Research, David Dodge was the chair at the time, and I'd worked with David when he was Deputy Minister of Health here in Ottawa. David asked me if I would consider putting my name forward to become president of CIFAR. I thought that would be interesting. It certainly played to what I've been interested in for a long time, which is to bring great scientists together to do great science and to have impact on the world. And so here I am. I've been president of CIFAR for the last 3.5 years, and I just have been having a great time.
Excellent, thank you. So why don't you tell us a little bit about CIFAR, the Canadian Institute for Advanced Research?
So CIFAR is a unique organization. I think it's unique not just in Canada, but it's unique on this planet in the sense that what we do is, and have done for over 30 years, is identify a really important question, a question of importance to the world, and then identify the best researchers in Canada and around the world to come together on a sustained basis, sort of typically 2 or 3 times a year for 5 years, to have deep conversations about that issue, or that problem. And what we are looking for is a whole new take on that problem, sort of a paradigm shift of thinking on an important question. And I think we've had great successes, actually, over the years. So we're not a funder of research. We are a convener of great conversations of really super people. And our purview is everything. We're not limited by discipline. We're only limited by what we consider to be an important question. And so after I started, we've made a number of changes, which we're calling CIFAR 2.0, which is meant to signify 2 things. One is the idea of bringing together great people, I think, is as important, in fact, even more important today than it was back 35 years ago when CIFAR first started. And I say that because I think the questions and the problems facing the planet today, from climate change to terrorism, are much more complex and much more pressing today than they were 35 years ago. And secondly, though, everything else has changed. How science is done, how science is funded, all of that has changed, and expectations of young people who do science. And so we have to change. And so we're changing. And so we've said we are really committed to 3 things. One is we're committed to creating transformative knowledge. 2, we're committed to knowledge outreach, of putting relevant stakeholders and the people who are creating new knowledge together so those stakeholders are better positioned to act. And stakeholders can mean policymakers, people here in Ottawa, for example. Stakeholders can be people who are involved in service delivery and social service organizations. Stakeholders can be venture capitalists. It really depends on the area we're talking about. And third, we're committed to really providing the best training for the most promising next generation of young research leaders. I think that's really important. So and we've embarked on this, and we're on a great journey, I think. And I think
Excellent.
yeah.
So you mentioned that you've had some recent big successes. What would you say are some of the big wins that CIFAR has had?
Well, I think there's a couple. One is, if you think about artificial intelligence and smart cars is what the public knows about, robots, that has its origins. Very few people, even in Canada, know this, in CIFAR, in a CIFAR program called Neural Computation and Adaptive Perception.
Okay.
And it started about 11, 12 years ago. Jeff Hinton at U of T, University of Toronto, and Jan LeCun at NYU, the New York University. And they had this idea, when everybody else gave up, that if you put together neurobiologists, physiologists, and computer scientists and mathematicians, you could somehow teach a computer how to learn. And I'm using those words loosely. But you could write algorithms for what's called supervised learning, or what Jeff Hinton would call deep learning. Well, Jeff is now a distinguished scientist at Google, and Jan LeCun is now a distinguished scientist at Facebook. And the reason is because they've actually cracked that nut. And so all the stuff you read about robots and smart cars all have its origins in a group of around 15 people that CIFAR convened over the last 10 years, really working hard to figure out how to do what Jeff calls deep learning. It's all supervised learning. And that program still exists. And it's now setting us up on the next challenge, which is unsupervised learning, which is more closely aligned to how humans actually learn. So that's one, I think, great example. I think another one, if I could take another
Absolutely,
3 minutes, I think the whole issue around the importance of early childhood learning and early childhood development, and highlighting how important the first sort of 3 years of our life is, setting ourselves on a trajectory for the rest of our lives of cognitive development and physical and mental health. Again, that really was championed, and a lot of the science came out of early CIFAR programs going back to the 1980s and 1990s. And more recently, that program, which is now called Child and Brain Development, it's sort of evolved over the years, work out of that program led to the very first evidence for what's called epigenetic changes. And what that means is that experiences that a child has in their first 3 years of life actually causes changes in their DNA, in their genomes, that changes the patterns of genes that are expressed in the brain. And that's really an explanation, as far as we can tell at the moment, for this trajectory that goes on way beyond the first 3 years of life. And it probably relates to the fact that during embryological development and during that first 3 years, a child's brain is still developing. And what's happening is that there are neuronal connections going on that are reinforced by learning. And so a child who's exposed to a sort of an optimal learning environment, what's happening there is that their neurons are really maxed out in terms of how well those neuronal connections are being made, as opposed to a child who really has limited opportunities for learning. And so that impacts hugely on public policy. And if we think back to this past election campaign, the very first policy issue that all three major party leaders came up with is issues around early childhood development. And I had to smile to myself when I sort of realized that. And they came up with different policies that aligned with their own party's sort of ideology, but it was the first policy. It all came, again, out of a CIFAR program that started back in the 1980s and 90s. And I think what we brought to the table was science and evidence. And I think that is what's so important in developing robust public policy.
Okay. So CIFAR obviously takes on topics from a wide range of disciplines. Just two that we've talked about right now are early childhood education and deep learning artificial intelligence.
Yeah.
How does CIFAR go about deciding which topics and which subject areas fall into your mandate of finding that transformative opportunity for change?
Great question. Right after I started, we launched for our very first time what we call the Global Call for Ideas. And we invited anybody in the world to come forward with an idea for a new CIFAR program. And we had several criteria that we were looking for to consider what would be a good new CIFAR program. One was it had to address a question of importance to the world. Secondly, it had to be interdisciplinary. We do not believe in disciplines as a way of thinking about a problem. Most problems actually fall between the cracks of disciplines. And third, we wanted it to be international. In fact, we insisted it be international. And fourth, we said it should build on strengths here in Canada. Even though we're global, we're a Canadian-based organization. Our funding largely at the moment comes from Canadian sources. And then we had peer review. So we invited really an eminent group of scientists from around the world, social scientists, physical scientists, biological scientists, etc., to help us whittle down the 270 letters of intent we got down to the final 4. And those 4 are going forward. And they range in topics from the relationship between our brain and mind and consciousness, a green energy program called Bio-Inspired Solar Energy, the molecular architecture of life, and the microbiome and humanity. Very different areas, and we could have funded another 5 or 6 if we had the financial and physical and personnel capacity to fund more. But there's a lot of really important questions that one can think of. These were judged by those criteria to be the most promising, and indeed they are incredibly exciting, really exciting.
Yeah, absolutely. I've spent a bit of time at the CFAR website, and it's just a wealth of great ideas.
Yeah, I feel like, as a scientist, a kid in a candy shop when I go to a CFAR program. Everyone is such a delight, because when I've asked CFAR fellows, and we have close to 400 fellows now from 18 countries in over 110 institutions. So when I ask them why they come to one of our meetings, they all say pretty well exactly the same things. They come because of who else comes. It is really a who's who in that area of research. And they come because of the question. The really important questions, really interesting questions.
Right. So to segue off of that, what do you think are a few of the potential new technological or social developments that have the most potential to transform our economy and society within a time frame of the next 10 or 20 years?
Yeah. Well, I've already mentioned artificial intelligence. So I think.
Do you think that's on the time frame of 10 or 20 years that?
Yes, I do.
Really?
Yeah, if not less. And I think I should say a caveat up front. I think we as a species are really bad at predicting the impact and the timelines of new technologies. We're lousy at it, and I'm probably lousy at it. But you've asked, so I would say artificial intelligence, I think, is going to transform transportation. It's going to transform advanced manufacturing. It's going to transform our homes. It's going to transform the nature of employment. There'll be ethical and social issues. If robots can do everything, what do we do, kind of thing. So I think there's all kinds of issues, some really positive and some perhaps worrying, but that's true for any new technology, any disruptive technology. So I think that's one. I think the second one, and again, I think it's already happening, and I've written about this, is precision medicine. I think our healthcare system is going to be transformed because we actually are going to start understanding complex diseases. If you think about diseases like cancer and mental health issues, so we are pretty close to understanding the most intimate molecular details of a cancer cell, why it behaves differently than a normal cell. From that understanding, we're starting to get really transformative new approaches to treatment. It's really transforming cancer research. So we're starting to see that kind of precision medicine happening now. Now, if you flash forward to mental health, we know almost zero about the brain. And as a result, we know almost zero about mental health. We know almost zero about Alzheimer's disease and dementias. That's going to change with the power of genomics and molecular technologies now. And out of that, just like with cancer, I'm pretty confident will come new ways of diagnosing and new ways of treating disease. And I think that's going to transform healthcare. And again, Canada has an opportunity to follow. We have to make a choice. We can follow or we can lead. And obviously, I feel we should be leading.
Absolutely, yeah.
Yeah.
So what do you think are some of the moral, ethical, and policy dilemmas that we'll be dealing with in the fallout of a lot of this rapid technological change?
Yeah.
So as an example, like if 90% of people are not just unemployed, but unemployable as a result of new technology, how does our society adapt to that?
Yeah, good question. And I always give the example that when TVs first started, and I can remember sitting in front of the TV as a young, 6-year-old, and my mother saying, "Don't sit so close to the TV, the x-rays are not good for you."
Mm-hmm.
So that's what parents were worried about. That's what we all were worried about, was the x-rays. What we should have been worried about is the content, the programming.
Yeah.
So I think we're really bad at predicting the negative impacts of new technologies.
Right.
So I'm always kind of nervous about doing that.
Yeah. The unknown unknowns.
Yeah, exactly. But at this point, 2015, I think what we can say is that with artificial intelligence, once we start developing smarter and smarter machines, and by the way, this has been going on for 100 years.
Mm-hmm.
Don't forget, tractors replaced, horses and manual labor in developed countries.
Mm-hmm.
If you go to even China and India today, it's still manual farming.
Mm-hmm.
We have tractors, so we already have smart machines in agriculture, and in car manufacturing. There's robots already. So I think we're kind of halfway there already, but I think we're going to see just more of the same. I think we'll see more and more people will be displaced from working in factories to actually writing the software for smarter robots. Mm-hmm. And I actually think that's a positive thing. There will be some dislocations as the nature of employment changes, but that's not entirely a negative. In some ways it's a positive. But I think it does highlight the importance for Canada of education and research and staying on top of where this whole field is going. Otherwise we risk training people for jobs that will not exist 10 years from now.
Mm-hmm. Excellent. So getting near to the end, what would your advice be for policymakers in terms of designing governments and designing policy machines that can basically exist and thrive in a world that is often going to be very unpredictable and changing very rapidly?
So I think I don't expect a policymaker, for example, to know the details of how an iPad works, right, or how even a robot works. But I do worry that in the talk, certainly since the election, about evidence-based policy making and the role of science in government, all of this is great, but policymakers need to be able to understand when they need science input into making policy, and they need to be receptive to it. So it's sort of receptor capacity more broadly. And so I think the challenge for policymakers, and it's a tough one, is no matter what field they come from before they were elected, or if you're a senior civil servant, they're not going to be content experts in artificial intelligence or in precision medicine, nor do they need to be. But they need to have the capacity to realize when they need input and scientific advice in the process of developing public policy. And so I think that's a sensitization issue that the most senior members of government have to be aware of, and make sure to push down that everybody within government understands when they need scientific advice and scientific input.
Absolutely, yeah.
Yeah, and I think that's, other countries I think are there, and they're ahead of us actually, I feel. So the UK probably has the most advanced science advice machinery in government. And I think from the Prime Minister on down, I think there is a broad appreciation of the importance of science in not formulating public policy, but helping to inform public policy development. I think New Zealand with Peter Gluckman as the Chief Science Advisor, and Peter will be speaking shortly here at the Science Policy Conference. New Zealand, for a small country, is also pretty advanced in kind of having that receptor capacity. So I think we can learn from other countries in terms of the importance of science in helping to inform public policy.
Absolutely, yeah. Well, I could ask you a million more questions.
Probably could.
But I believe there's a science policy conference going on as well.
Yes.
So it's my final question before we wrap up. For those who are watching this video, where can we find more information about your work, about CIFAR, and about the things that we've been discussing right now? Where can we find more about that online?
Well, you go to www.cifar.ca. That's our website. and there's lots of information there. If you want to find even more information, join our knowledge circle. Costs a few bucks, but you'll get sent our circulars, some of our publications, which I think are great, and you'll get invited to all kinds of events. When our CFAR fellows speak, I'm always amazed at just how interesting they are, and the kinds of people who come out to hear some of our fellows speak. They're just a fantastic group of people, and we have some of the best researchers in the world, really, in that group of people, Nobel laureates on down. And so that's I think probably the best way. But our website's a good place to start.
Excellent. Well, I think a lot of people will be checking that out. This has been an absolute pleasure, very interesting conversation.
Yeah, my pleasure.
And thank you so much for joining us.
You're welcome, Connor. Yeah, thanks.